an AP calculus in order to be great. Don't hesitate to eliminate the rate. To eliminate the rate, you need to integrate. Integrate, integrate. You really can be great. That's it.
I love it.
Thank you, yes. And the song does actually have to do with what we started talking about yesterday, which was, you're given this table right here, and this table is of what?
That is
Numbers.
Numbers which represent a
function.
function which represents a,
Graph.
think of the song,
Rate.
a rate. Thank you, a rate.
I just think of it.
Oh, it says rate right there.
Yes, 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 yes,
I didn't know I was
yes.
I think that's a gold star on my behalf.
Yes, thank you, thank you. Don't hesitate to eliminate the rate. Right?
Yep.
So how do we eliminate the rate? You need to
Integrate.
integrate to eliminate the rate. And what happened was, I was at one of these, when you get into the teaching profession, especially in calculus, they have these training sessions every year that you go to test for the AP testing and so forth. And it's called an AP prep session. Anyway, you go to this session and you get with all these teachers. And there were these teachers from this school out by Eastland. You know where Eastland is?
No clue.
Eastland is, you go west on 30 towards Abilene.
Oh,
It's
okay.
one of those, it's out there, kind of halfway between Fort Worth and Abilene. And they were this little school, and they said, to eliminate the rate, you need to integrate. And so here I am, and they had that. And so I shared some of my songs with the class, and then they came up with that. And so I thought up a song for it, came up the next day and performed. So anyway, that's what, pardon me?
41.
41, yes, thank you.
You're too far ahead.
So anyway, yes, we have a rate, and what do we need to do to eliminate the rate? We need to integrate. And so now, use a left Riemann sum with subintervals integrated in the table of RT below. And so, here we have these subintervals. And how many subintervals do we have here?
6. Or 5.
5.
5, but you said 6 first, right? Why is 5 the correct answer?
Because there's 5.
Because there are 6 boxes with only 5 numbers.
Yeah, 6 boxes, and so you're gonna have 5 intervals between the numbers, right? So you'll have one subinterval here, another here, 3, 4, 5. And so yesterday, how did I tell you to start setting this up?
To do the, what's it called?
Okay, estimate of
Oh, and then the little, like, integral sign.
integral sign of what?
RT,
0 to 15,
and then it's the R, and then D.
okay. R of t, and what goes here? dt
Oh.
equals, and then how many intervals we said? 5, right? Boom,
Blinky bunnies.
boom, boom, and I'm going to put down here, boom, boom, right? All these. And what are the units going to be?
Well, if it's hours. Wait, I'm sorry. Okay, wait. Gallons per hour. So gallons?
It'll be gallons. But I'm kind of revising my thought here, because here's the table, but what are they asking about?
3 to 12.
3 to 12, that changes things, right?
That means it'll be
So let's go fix that here. Is that going to change our number of intervals too?
Mm-hmm.
Yeah, so how many intervals are we now going to have?
3.
3 intervals, so we're just going to erase these two. So what it is, this is an example of upon more careful reading, right? But I'm sort of glad that we wrote those first, because that really helps us go through the thought process, I think. Okay? So let's go ahead and fill in what goes here. So now we're talking about 3 intervals. It says left Riemann sum. So what's going to go here? What is going to be the width of each of these rectangles?
3.
So 3, 3, 3. And I kind of like to do it like this, where I fill these in one at a time, and then left Riemann sum, what number is going to go in here? Now we're talking about the height of the rectangle. We have the width of the rectangle. It's equal width. And what's the height of these rectangles going to be?
10.4.
Yeah, so the left, what you do is you're talking about this interval here, and the left one is going to be this one right here. So we're going to put 10.4 here. And what goes in here? Okay, now you're looking at this interval. What's going to go in here? 10.8. And the last one is going to be 11.2.
I was just really struggling to read it on the screen when it's on my paper.
Pardon me?
I was like squinting because I can't read it up there and it's right in front of me.
Oh, okay, yeah, yeah.
I'm just like,
Okay, yeah. Yeah, most of the stuff we do. Okay, and then do we have to do any more than this?
nope.
No, we have to do anything more than this. That is good. We have fully answered the question, and we are good.
Easy peasy lemon.
Questions on this? Now, what I want you to do is look at problem number 3, which is very similar. By the way, these types of problems are usually accessible from tables. Sometimes they're from graphs, but most of the time it's table data that makes it happen. So go ahead and look at number 3, and we will talk about that shortly, all right? In fact, on that last one, I probably should have used the word approximate instead of estimate. Why should have I used on number 2 the word approximate instead of estimate? Why would approximate be better than estimate for problem 2? The reason approximate is better because that's the actual word in the problem. So if you can reference the actual word in the problem, that's better. I mean, a little better. It doesn't mean that estimate is wrong either, because it really is a synonym with approximate, right?
So, okay, I think I'm smart actually.
This one here is this problem 3 introduces something called a midpoint Riemann sum. So see if you can figure it out. It is a little different. So if you don't get this thing cold right off the bat, I can understand why. But they do tell us 3 rectangles. So we know it's going to be what? Blank, blank, blank. And what are the units of our answer going to be?
Feet.
The units will be feet. Okay, here's what I'm going to do. I'm going to recruit one of you
Oh no.
to help me with this. I'm going to spin the number wheel, the name wheel. Remember that? We haven't used it in this class yet much this year. Have we used the wheel of names at all this year?
Yeah.
Yeah, we have a couple.
We have a couple times. We can use it.
Oh no. We really don't have to.
It's gonna be questions.
No!
Yes!
All right, Aaron. Does everybody else breathe a sigh of relief that Aaron was chosen? Okay, Aaron, what do we got?
Well, you gotta do the estimation
So estimate,
of,
and I can abbreviate that, is that okay?
yeah, that's right.
Okay,
It's 0 to 12,
0 to 12,
V of t, dt.
equals, okay.
That'd be 4 times 30
4 times 30,
plus 4 times 44 plus 4 times 35.
Why?
yeah, why? Just defend your answer.
Where'd that come from?
Defend your answer, yes. That's part of
Well,
the,
because it's easy, you gotta use the midpoints, and the midpoint of 0 and 4 is 2, and so we use
Oh.
2.
okay, so Aaron was
And then the midpoint
explaining
of
over
8
here.
is 6.
He says if you take 3 intervals, you got to be looking at these intervals here, these 3 here, and that you're, of this interval here, whose rectangle whose width is 4, and he has 4 for each of these, right?
Yes.
The mid value for this first rectangle is going to be 30, and then of the second rectangle, the mid one's going to be 44, and of the last one, the mid value is going to be 35. Okay? That is some good work right there. Okay, very good. I will recognize Aaron's contribution to the
No
class
way.
today. There we go.
No way. Yes.
Yeah, so here, right here, we get Aaron some special recognition.
I love
Go
recognition.
Aaron. Go Aaron.
All right.
I have so many people I want to thank for this song.
Everyone who's the wish that your name got picked up.
Yeah, I want to thank
Okay, but-
people with names.
But this is not that hard, is it?
No.
Not that hard, right?
Yeah, it was pretty easy. I don't know why the word midpoint confused me like that.
Yep.
Yeah, that's right.
I'm just dummy.
But there are, so the next note card here we go to is 42. And 42 has to do with, it's the same thing, but
Same thing, different.
unequal widths
Nice.
with rectangles that are not, and I guess the reason for that, I hope, will be obvious when we look at a table. Otherwise, it's the same. I'm not going to dwell on this, but we come to this thing here, and why are we not in this problem right here going to be using equal width rectangles? Why are we not using equal width rectangles on this one? Let's look over here. Look at the table. Why are we not using equal width rectangles?
Because we don't have that.
The data is not supporting equal width rectangles, right? So we approximate the values with the 5 subintervals above. Okay, and then what happens is they ask this follow-up question: is this numerical approximation less than? So actually it's like a 2-part question, right?
two part, but I don't know what it's saying.
Okay, all right, so let's go ahead. But can we look at the approximate, can we approximate using the value first? Yes, so let's do part C, let's start this out. So we'll say, I'm gonna get a skinnier pen because I don't have a lot of writing room here. So it says approximate, so approximate approximation of 090 r of t dt
Or TDT.
equals, and it says 5, right? So we have 5, 1, 2, 3, 4, and 5. And then what are the units going to be?
Gallons.
Units are going to be gallons.
Nice, I mean,
Very good. She eliminated the rate. She's been paying attention
so I can start
in
to.
class today. Very good.
What?
She did not
I
hesitate.
can start to.
She did not hesitate to eliminate
The rate.
the rate. Yeah, you are deserving. You are deserving, Kylie. You are deserving.
I appreciate
You will
that.
get your just reward. All right. And so now we go ahead and say, okay, here are the 5 things we have. And so the rectangles are going to be, this first one's going to be a 30, right? And next one's going to be 10 width. And the next one's going to be another 10, right? And then this next one's going to be
20.
20
20. It's 20.
and 20.
And then 10. 20?
It says, now it says left Riemann sum, right? So what numbers are going to go here?
So it's gonna be, the like one, so like, okay, so like 30s would be 20.
So the first one will be 20. Where'd you get 20 from?
It's,
Right here.
yeah, so R2 0.
Yeah, so R of 0. Yeah, that's right. R of 0. Very good. And the next one's going to be 30. Now there is something, then you can just write this like 40, 55, 65, right? And what do we do with this 70 here? What happens to this 70 right here? What do we do with
Just
it?
ignore it.
Yeah, we just ignore it because
It doesn't exist.
this would have been good for a right Riemann sum, but not helpful for a left Riemann sum. And then, and so now, so this is the answer to the question. Now here's one thing that was a little weird as I looked at the table. Now when you looked at the other problems we had tables going which way? We had sideways table, right? Well, in this case, the table is a vertical table, but the graph itself is going to be, so let's go ahead and just sketch that in because that's going to help us to answer this next question. Is the numerical approximation less than the value of, and so they have the graph drawn in like this. So let's go ahead and draw this in. We have 30 times 20, so here's our first rectangle, right? So here's our first rectangle right here like this. In fact, I'm going to make it red just to make it more visible. Our second rectangle is going to be width of 10, but a height of 30, right? So we have a 10 by 30. So here's our second rectangle. And I can just change colors on these, can't I? And then the next one is going to be a width of 10. It's going to be 10 by 40. So we have that here. Now I'm going to draw a yellow one. The next one is a width of 20 and a height of 55. So here is our yellow one right here. And last one, I'll use a purple one. We have 20 by 65. And so we have this here. So now can we answer the question? Says, is this approximation going to be a underestimate or an overestimate of this thing here?
Under.
Okay, Aaron says under. Kylie says yeah.
Yeah.
Gavin
Yeah.
says yeah. Hannah says huh.
Okay.
Question, it's up to you, big boy.
But anyway, why do we have why is this under approximation?
Because it's like under the curve the whole time.
Yeah, under the curve, right, except at these points. And what this tells us is one thing. When you have a left Riemann sum of an increasing function, that's going to be a underestimate.
Yes.
Now, in this particular case, I guess it depends on what we're using it for. And so that's Aaron's explaining the meaning, right? Because we're under the curve. Do you realize when you conceptualize a problem like this, that as a mathematician or as a person, you're going to be able to a lot of times choose which one to use, right? Because you can see that using a left Riemann sum is kind of arbitrary. Why would you choose to use a left Riemann sum, a midpoint, or a right Riemann sum? Because you know they're not going to be exactly the same. Why would you choose such a thing? Think of the real world. Think of the real world, right? We talked about P-vang, right? Physical, verbal.
I have a Nerf card of little P-Bang. I made it myself.
Right, why would we use a right Riemann sum, decide to use a right Riemann sum instead of a left Riemann sum, as opposed to the way the problem did it? Think of the real world, okay? Look at the problem. What is the problem asking about?
What if, like, I don't know, it seems like Carson's kind of arrogant. He's talking about planes.
Oh, that's right. That's right, Carson. We're talking about planes. All right. That's
What
right.
is it,
I like
Carson?
that. Okay, Carson. That's what. Okay, very good. That's a good deflection there, Aaron. All right. Okay, Carson, you're flying a plane, right? And what do you have to have in your plane to fly it?
Lots of things.
Fuel.
Just say fuel.
But the one thing that will save your life, or not, will be having enough fuel in your tank, right?
You would rather have too much fuel than not enough fuel.
That's not entirely true.
Yeah, it depends on the weight, right? So there are different things to consider, but generally, but what I'm trying to get at here is that there might be a situation where it would be to your advantage. If I'm really worried about running out of fuel, I'm going to pick my underestimate of how much fuel I used, depending on which way I shade for my margin of error that will possibly save my life, right? Or whatever. But yeah, Carson's exactly right that the weight of the fuel may not entirely be true, because that's going to be more fuel to carry too. And so there's going to be something you have to consider. But in general, you want to have more than enough fuel, so you won't have to do a dead stick landing under no power. Hopefully on land and not in the water, right? Yeah. Did you ever in your pilot training do dead stick landings? You did them, right? Without power?
I mean,
Is that part of the training?
You never just completely cut it off now.
That's me shooting.
Okay.
I mean, like I've
So you do it under low power.
done like simulated stuff.
You do simulated. So you simulated that situation.
So
Okay.
you always, when you're landing, you always like at the very last, you completely pull power back.
Yeah.
Huh?
Now we get to part D. Between b equals 0 and 90, what is the meaning of this dRT in terms of the fuel. You have 0 to P, RT, DT in terms of fuel consumption for the plane. And what do you do? What is this thing going to mean here? The what?
It shows
The amount
of fuel consumption.
of gallons used in B seconds, right?
I think it's minutes.
B minutes, thank you, because gallons per minute.
What did you think?
B minutes, thank you for kissing.
Why did you spell minutes wrong?
I spelled minutes wrong?
Yeah, I used an S and put E.
Oh, you did? Okay, yeah, it happens. It happens.
Talking about yourself in the third person. Or no, second person. Poop.
And I saw Hannah doing the color coding with the rectangles too. That was good. Right, Hannah? You like doing color coding, Hannah?
When it comes to graphs.
When it comes to graphs? I want to tell you one thing I did that was in my college training. I majored in engineering geology, and one of the things we did was we did this summer field camp, and I went out to the desert of western Utah and was given this plot of land to do a geological map of. So I went and examined what kind of rock and soil was there, and I made a geologic map. But one thing that was really cool was in making the map, I made a colored map, which is typical for those types of maps. So I thought, man, this is cool. This is just like being in kindergarten again, making maps, and just enjoying that process. Okay, a common example worksheet uses the problem. Here we have Riemann Sum's classworks, and we're looking at the picture to the right. We'll look at 4 techniques: right rectangles, left rectangles, midpoint rectangles, and trapezoids. So we're talking about this whole area. Yeah, so trapezoids. We haven't talked about trapezoids yet, have we?
Nope.
So we're gonna sort of pre-introduce trapezoidal rule. So we look at this, and here we have right rectangles and left rectangles, and you can kind of see that depending on whether the graph function is descending or increasing, a left or right Riemann sum might be an over or underestimate depending on which way the function is going. Like in the previous problem we looked at, we had a left Riemann sum was an underestimate, but the right Riemann sum with the same graph would have been an
Oh, it would have been. What was the question?
overestimate, thank you. An overestimate, thank you. So anyway, and now we have the example of midpoint rectangles
Trapezoid one.
and trapezoids.
That looks pretty perfect.
Now what you can do for the trapezoid really matches kind of well. Now,
Looks like a roller coaster.
it's like a roller coaster, but it's going to be, is this one here, using trapezoids, is that going to be an overestimate or underestimate?
It looks like it's barely going to be.
Yeah, looks like.
Yeah, it'll be barely an underestimate, and the key is that if you have a concave down curve, a trapezoidal sum is going to be an underestimate. If you have concave up, a trapezoidal sum is going to be an overestimate. Very good, very good. Paying attention in class. Like that. Then we get into sort of the nitty-gritty of the formulas, but to me there's not a whole lot to that because it's just, you can sort of look at it and you don't have to get into this kind of academic detail on these things. So we're going to go to this one right here. It's the interpretation of area. You jump out of an airplane. Let's see what the instructions they give here.
I like paper. Okay, good.
Okay, what I want you to do on this one here, on number 1, is let's do we'll do, okay, for number one, interpretation of area, I want you to do, we'll do it by groups here.
Nice. Aaron.
Okay, you guys over here are one group.
Gosh darn it.
You three are one group, and you two are one group. Okay, so we're just sort of, all right, what I want this group here on the west, you're the west group, this is the east group. West group, I want you to do a left Riemann sum of this.
Oh no.
The east group, I want you to do a right Riemann sum.
Oh, awesome.
Okay, so I have one quick question.
Yes.
How do you do it?
It would just be, like, it would just be to the right, wouldn't it? Wouldn't there be, what would I do with the last one? Doesn't have a right buddy. Oh, I would just, no, still lost. I'll figure it out for myself.
So you guys are doing the left Riemann sum, right?
Where's this at?
It's the next go, right there. Right on the top to the top. It's right there. Oh, looks like we're out of time.
We're getting there. We're getting there. We have a few minutes of class left. And I can wipe down the desks too if I need to. I'm cool with that.
Wait, we're doing the right one?
You're doing the right one. You guys are doing the left.
It's a group thing. Come on, guys, get in the group. Come on, huddle up. My group's boring.
Hannah, sometimes I'm scared of you. That's it.
Hannah,
They're not grouping up.
how is it possible for a group to be boring
Because I said
with you in the group?
I'm in the group.
Well, there's something called,
You play football.
Hannah, but there is something called social distancing though too.
Yeah.
This is sort of a weird era. This is sort of the era we live in. I don't want to.
Nothing.
Go ahead.
I don't want to, when I have the contact tracing interview with Mr. Casas, I don't want to have to say,
I did it.
Okay.
okay, did you guys finish it over here on this?
No, they're not getting in my group.
Did you Carson do this?
Almost.
Okay, here's what I'll do. Here's what I'm going to do here. I'm going to write my interpretation of what the right Riemann sum is.
That's me, right?
Yeah, the right Riemann sum. And I'm just going to get, and this is my prediction. So this is the right Riemann sum, estimate of 0 to 5, v of t dt,
That's what we like to see.
dt, it's dt, equals,
I can't do that.
equals
You gotta have your lips just.
60 plus 40
Nice.
plus 25 plus 10 plus 0 feet. Is that what you got, Kylie?
Yep, that's
You were
what I
leaving
got.
off, okay? So this is our right Riemann sum right here. That is a correct answer for right Riemann sum.
Hannah's dead.
Okay, what does our left Riemann sum look like?
What is it, guys?
Well, Hannah's dead, so she can't answer. We shot her.
No, she's laughing. She's in love.
I hit my head really hard. I'm not going to read on the binder. So bad.
Are you okay?
What did I just say?
Okay, what is this? What is going to be our left Riemann sum here?
You just flip the numbers around basically the direction you're looking at this one.
Okay, so here's the right Riemann sum. What's the left Riemann sum going to be?
I can answer. Can I do the start?
They shot me. I can't talk.
You just talk. She can talk.
Kill her again.
Okay, we used the right numbers here, which were 60, 40, 25, 10, and 0. What are the left numbers going to be?
Is it 0? Is it 0, 10, 25, 40, 60?
No, it's like the line between the 0 and 1s where I like mark it.
Okay, I'll put the-
right.
I'll put the answer to this one. The answer to this one is 88 plus 60 plus 40 plus 25 plus 10 feet.
Mom.
Somebody make him smile.
Oh, your mom.
Okay, do you see the distinction between the right Riemann sum and the left
Where's my
Riemann
mommy?
sum?
I draw, I use
Who else do I talk to?
the like line of the box to do right and left.
So you used a box to right and left, so you made the box, so you said this is gonna be your right, and this will be your left for
Yeah,
that
like
one
we
box?
use the line in between it, like that
And the
one.
line in between is the demarcation between the two,
Yeah.
okay? Yeah, so that's one way to look at it.
Okay, I
So-
understand.
I just popped my hip.
You did?
Yeah.